Alright, so today we're going to be working on the different transformations that we have. Okay, so a transformation is a change in the size, shape, or position of a figure. So if you notice from here, we have the smiley face and it slides over. Okay, well that's going to be a translation. Then here the smiley face doesn't change size, but instead it rotates. That's called a rotation. And we're going to go over all these. Over here it flips over, and if it flips, we call that a reflection. And then the last one, the smiley face got bigger, and it can also go from big to small or small to big. We call that a dilation. Okay, a pre-image is the original figure, and an image is a result of a transformation. So pre-image is the image we start with, image is the image we get after the transformation has occurred. Prime notation is what we use to identify the image points. So for example, the image of point A is A prime. And so the only difference between those is that A prime has the apostrophe at the top of it. So we would go from A to A prime, B to B prime, so on and so forth. So the first one we're going to look at is dilations. And again, if I'm going too fast, it's fine. Pause the video as you need to. A dilation is a transformation in which a figure is reduced or enlarged. By using a scale factor. So to dilate a figure, multiply the coordinates of each vertex by the scale factor k. Alright, so this is the algebraic rule. Now don't be scared, the algebraic rule is something that you have to recognize and that you have to use on the test so that we know what we're looking at. So they're going to give you a picture and they're going to usually ask you what is the transformation that occurs, and you have to be able to look at this and determine what that means. Okay, so if we ever see a point xy, right, we're always going to start with xy, and it's going to transform into kx, ky. K being the scale factor I multiply by. When k is larger than 1, the dilation is an enlargement, and when k is larger than 0 but less than 1, the dilation is a reduction. So we should know that. If I multiply a number by something larger than 1, so like 2 times 2, I'm going to get 4, which is a bigger number. But 2 times 0.5 would give me 1, and 1 is smaller than 2. Okay, so triangle ABC is dilated with respect to the origin by a scale factor of blank. We're going to figure that out to create the image triangle ABC prime. Okay, so ABC is the smaller triangle, ABC prime is a large triangle. Again, we know that because of the apostrophe. So ABC, they give us the points for those, and we need to plot the points for ABC prime. So A prime is at 6 and 2. B prime is at -2, -2. And C prime is at 0, 4. And again, X determines the movement left and right. Y is the movement up and down. And it's always going to be X and then Y. So then we need to look at how they changed. Well, there's a couple ways we can do this. We can either do the new divided by the old. Right, so in this case, let's say we do A prime and A. So new, the image, would be A prime, and the old, or the pre-image, would be just A. And if we're going to do that, it's best to just choose either the x value or the y value. So you're either going to do the x divided by the x or the y divided by the y, but never do the x divided by the y. So let's do 6 divided by 3. That's the x value of a prime divided by the x value of a. 6 divided by 3 would just be 2. So my scale factor would be 2. So what I'm saying here is I'm saying that ABC prime is twice as large as ABC. And if we look at each point, that should be true, because 6 is twice as large as 3. 2 is twice as large as 1. Negative 2 is twice as large as negative 1, etc., etc., etc. Okay. Now the algebraic rule we would use to describe this dilation is we start at a point x, y. We're always going to write this first. xy transforms into 2x 2y, because I'm multiplying the x value and the y value by 2. I'm making them twice as large. So we would do draw a rectangle WXYZ in its image after a dilation with a scale factor of 1/2, and then identify the type of dilation. So the first thing we need to do is we need to plot the points. So let's plot them. So we have -2, -2, -2, +3, 5, +3, and 5, -2. So then we would plot those. So this is W, X, Y, and Z, and then connect the dots. Alright, and we're going to transform those by a scale factor of 1/2. So it's all we're going to do is we're going to take every single value, every single point value here, and multiply it by 1/2, or 0.5, because that's a decimal version of 1/2. So -2 times 1/2 would be -1. -2 times 1/2 would be -1. So W prime is going to be at -1, -1. Then -2 times 1/2 would be -1. 3 times 1/2 would be 1.5. So -1 and then 1.5. Call that x prime. Y prime would be 5 times 1/2 is 2.5, because half of 5 is 2.5, and then half of 3 is 1.5. So then we would go to -2.5, 1.5, and we would call that y prime. Then z prime, 5 times 0.5, or 5 times 1/2 would be 2.5, and then half of -2 would be -1. So we go 2.5, -1, call that z prime, and then connect your dots. And that's how we would do that. So the algebraic rule here for dilation would be xy transforms to 1/2 x and 1/2 y. And then would this be an enlargement or reduction? Tell me what you think. And then because we are multiplying by a scale factor smaller than 1, this would be considered a reduction. And if we look at it, we will go from the blue to the green. So we go from a larger rectangle to a smaller rectangle, so we can reduce the size.